Welcome back to MATH10NIK tutorial series, and this is your teacher, Sir Ababa. For today's video tutorial, I am going to take up permutation. Before I proceed, I would like to acknowledge the authors of my reference book, which is EMATH, Worktics in Mathematics. They are Orlando A. Oronzi and Marilyn O. Mendoza, under Rick's Bookstore Incorporated. At the end of this video tutorial, you are expected to illustrate the permutation of an object, derive the formula for finding the number of permutations of n objects taken R at a time, and solve problems involving permutations. Since this is a video tutorial series, so don't miss my next upload. That is why if you haven't subscribed yet to my channel, please do subscribe and click the notification bell so that you will be updated for my next videos. To understand what is permutation, let us have this situation. Mrs. Pamo uses the 4 letters of her surname, P, A, M, and O, in different order to assign computer passwords to her 20 students. Each letter appears only once in a password. The question is this: are there enough passwords for Mrs. Pamo's 20 students? How many different passwords can Mrs. Pamo create? If you want to answer, just comment down below. An arrangement of objects or events similar to the activity in exploration in which the order is important is called a permutation. To find the total number of passwords that Mrs. Pamo can create, we can use a list or tree diagram. So we're going to do it this way. We're going to connect the letters. So first you have the first letter P, and then the next letter we have A, M, and O. So we're going to connect that. And then for the next letter, you only have M and O for your choices. And then after that, after connecting the letters, you can now list down the arrangement of letters. So all in all, how many arrangement? Okay, so we have 24 arrangements in which there is no repetition of letters and the order is important. So getting the 24 passwords out of the 4 letters P, A, M, and O using a list or a tree diagram is very tedious. Because of this, we consider other ways. The number of permutations. Hence, the number of permutations of 4 different letters is, so for the first letter, there are 4 choices. So you can choose any of the 4 letters to be your first letter. So it's either P, A, M, or O. So whatever you want to be your first letter. But of course, it is obvious to start with letter P, and then the next letter is A, M, and O. So for your second letter, you have now 3 choices, because the first letter has been taken already. For the third letter, you only have 2 choices, because 2 letter already has been taken. And for the last or fourth letter, you now have 1 letter. So by following the multiplication rule, we will multiply these numbers. So that is 4 times 3 times 2 times 1. So this process is what we call fundamental counting principle. Okay, so getting 4 times 3 times 2 times 1, this is the number of permutations in getting the 4 letters. So this is what we call 4 factorial. So that is denoted by an exclamation point. 4 and then exclamation point. That reads as 4 factorial. So 4 factorial is equal to 24. So again, the methods to determine the number of ways or the number of permutation or arrangement of objects is by listing method or tree diagram, and then the easiest way is by applying the fundamental counting principle. We follow the multiplication rule. To define what is permutation, a permutation is an arrangement of things in definite order or the ordered arrangement of distinguishable objects without repetitions among the objects. In general, if n is a positive integer, then n factorial is denoted by n and then exclamation point is the product of all integers less than or equal to n. So that is n factorial equals n times quantity n minus 1 times and so on up to 2 times 1. So as a special case, we define 0 factorial as equal to 1 because there is only one way to arrange nothing. There is only one way to arrange 0. So that is why 0 factorial equals to 1 and 1 factorial is also equal to 1. So that's it, my dear students. We have illustrated and defined what is permutation. So stay tuned and watch for the next video. So this is your teacher, Sir Baba, saying, in every problem in math, there is always a solution.